we are discussing about the atomic weight. Yes. So atomic weight is equal to weight of one atom of the element by weight of 1/12 of the carbon element. So like we said, no, it's like a comparison with they have taken the 1/12 means if the carbon is placed with, if carbon is 12 means one carbon atom consists of 12 parts. They have taken 1/12 in the sense if the element mass is above it or below it, it is based upon the 12 parts of carbon. Simply, if you want to see the video, I just show you the video so that it is very clear. Okay. So what is A here? A. For example, here the standard weight they have taken like 12 kgs like A. So here A is nothing but carbon. Understood this point? They directly not calculated by using protons and neutrons at that time. They have taken the standard weight like C12. C12 is nothing but one atom of carbon consists of 12 parts of it. So they measure with the 12 parts one kind of atom. Sure. They have taken only the standard weights, like how we measure the things. Okay. Understood or not? Kavya?
Ma'am?
Yes.
Now, how to do that? Means how to find
I said don't go in depth. These are animated videos. If you go in depth to calculate things, we need to go with the radio, this thing, all the like yes. Okay. Then we need to go for all like polymerizations and different concepts we need to go. Understood? So there we need to go with the cathode ray experiment and different kinds of experiment. This you are going to learn in your higher classes. Understood? In depth you are going to learn, not too depth. Like if you go with the higher like +1, +2, then you can understand to calculate. When we go with the thermodynamics and everything, then you can understand how to calculate the energy levels and everything. Understood?
Yes, ma'am.
Yes. Just to listen. If you have about the instruments and everything, how to calculate, that also I'll clarify. You just listen about the concept. This concept, you are going to calculate atomic mass units of one atom is equal to 6.022 into 10 to the power of 23 Avogadro's number. That you are going to calculate in standard 9 whole concept. Ronak, understood?
Yes, ma'am.
So if we go in depth, we need to cross the concept and we need to go to the other concept like mole concept. This you are going to learn in standard 9 chapter 2 mole concept. Okay, just we are touching all the fundamentals, like this stuff chemistry is nothing but touching of all the fundamentals. Almost we are going to touch like 9th you are touching and even 10th concepts also we are touching about the fundamentals. Yes, dear? Any doubts, children? Have you understood the difference between the atomic weight and atomic mass? Atomic weight is a concept given before, like without giving any idea about the number of protons and neutrons. At that time, they have taken the standard mass like carbon 12, and they have taken the carbon 12. Carbon consists of 12 parts. With each part mass of one each part, it's nothing but atomic mass units. This concept you are going to calculate, you are going to learn in standard 9, that is one concept. Okay, so this is the general formula to calculate the atomic weight. Weight of one atom of an element is divided by weight of 1/12 part of the carbon. Like how the video is completely related to this is like if they have taken the smaller element, they have taken the one part of from the 12 parts of carbon. They have weighed with one part of it. So the mass of the atomic weight of unknown element is 1/12 of carbon. That means if the mass of unknown element is one part of, among the 12 parts, one part of the carbon. Understood, children? Rona? Understood? Arya?
Yes.
Chemical formula. This is also very good concept. And this also you are going to learn in chapter 2 in standard 9, but we have given a bit idea about the chemical formula. Okay, so when we go with the chemical formula, what we'll say about the chemical formula? The representation of a molecule of a substance. The substance may be element or compound. The representation of molecules of a substance, that is element or compound, in terms of symbols and subscript numbers is known as its formula. Is known as a formula. So the formula is nothing but representation of an element, or a group of elements combined to form compound by presenting the number subscript numbers is known as its formulas. So to remember so many formulas, like in general we can't go with like thousands of formulas, no? According to our limit, according to our boundary, we'll deal with common compounds in every concept. Yes or no, children? So how much chemistry is a vast, like a big ocean. So we can't go with all the formulas, and we are not dealt with all the formulas. Okay. In general, we'll go with like 1 to 30 elements, you know very well, and you know the formulas also. Formulas are nothing but symbols of that particular element. When we go in depth about the molecules and compounds, we need to see the combination of different elements to form compounds. That compound formulas, how to write the compound formulas, now we are going to deal with. Understood? Understood? So here we can see the examples. Helium, neon, argon, krypton, and xenon. Their formulas are same, and element formulas are also same. Why? Because they are inert elements. They are inert elements. They won't combine with any other element or its own element. Like how hydrogen is combined with its own element, like H2. It's combining with one hydrogen, is combining with other hydrogen to form H2 gas. Understood, children? Like that, the element won't combine with own elements because they are inert. Because they are inert. They will be like that even in the atmosphere also. They won't combine with its own elements because they are inert. Okay, so their element symbol is same and formula is also same. Okay, so these are the examples. Elements with one individual atom having its own symbol, they won't combine with other elements, they are like inert. They don't have ability to combine with its own element. Like He2 won't be there. No. He is only He. Even in the elemental form, even in the combined form, you can see the combined form, there is no chance of combining with its own element or with any other element because it is inert. Inert means stable, standard. Done? Okay. So if you see the examples of few elements, H2, H2O, SO2, NH3, H2SO4, etc. All these are the molecules or compounds. Though they combine with the different elements, to form compounds. The compound shows only one property. They are stable. Their proportions won't change. The formula won't change. The formula is standard. The proportions are fixed in compounds. Okay. In water, the formula of water is H2O. Is anybody forcefully go and combine two hydrogens and one oxygen? No, it's a natural phenomena. This hydrogen elements combine to form two hydrogen atom, combine to form one oxygen atom to form water. Stable means they won't move or they won't interact with other elements to combine to form compounds. In the atmosphere also. Yes.
But yes, H2O is in many chemical formulas.
That's why it's not stable. It forms molecules. It forms compounds. That's what I'm saying. above elements. These examples are one individual atom of an element. That means they are stable. They won't combine with its own element or any other element. When we see the below elements like hydrogen, oxygen, sulfur and remaining elements, they are having capability to form compounds with other elements. So these elements are very useful. Even inert elements also useful for the what we can say any research work because they are stable. Standards also required. Understood? In the atmosphere, hydrogen is there, oxygen is there, helium is there, like inert element, helium is there. But hydrogen single element will always in the combined form with other element like H2. Always if hydrogen is here, one hydrogen is here one more hydrogen is there, then combine. What will they combine? To form H2 gas. To form H2 gas. Understood, children? If helium is present, helium won't combine with any other element, not even with its own element, it won't combine. Understood, Ronald?
Yes, ma'am.
So then only, if alphabets are there, 26 alphabets are there, if they are stable like that, what is the use of learning the 26 alphabets? They should combine, huh? 2-letter words, okay, 2-letter words, 3-letter words, okay, a big word, huge word, frames of sentences and everything. Then only communication is there. If elements are 118 elements are like that in their periodic table, what is the use of 118 elements? They should always in the combined form. They should always in the combined form. Then only there are new products are formed, new compounds are formed.